Hello, everyone, and a warm welcome to another exciting episode of Class Academy Webinars 2024, where with each episode we delve a little more deeper into the fascinating world of glass. Glass, as we all know, is a material that has undergone remarkable innovation over years. From simple transparent paints to highly engineered materials, glass has evolved to meet the demands of modern architecture, technology, and safety. Today, we will be discussing one of the most critical aspects of this evolution, which is fire safety glass. As our buildings and infrastructure grow more complex, ensuring the safety of occupants in this event of fire is very important. Fire safety glass plays a crucial role in this, offering protection that goes beyond just containing flames. It helps to control smoke, reduce heat transfer, and maintain structural integrity, the elements that are very important in preventing disasters and saving lives. Today's topic, Introduction to Fire Safety Glass, is especially important as it touches on the niche yet incredibly vital area of construction and safety. The understanding and applications of fire resistant glass is essential for architects, builders, and safety professionals, and this webinar aims to shed light on the nuances of it. To take us to this subject, we have with us today an esteemed expert in the field, Mr. Hatinder Vohra, Head of Sales of India, South Asia, Egypt, East Africa at Vetrotech Saint-Gobain. He brings with him an impressive 24 years of experience, with the last 20 years dedicated to the glass industry. Mr. Hatinder specializes in glass processing, product development, and most notably, glazed fire resistant solutions and fire safety compliance. His extensive knowledge is complemented by his active involvement in conducting fire safety workshops at various forums, fire departments, and colleges. Additionally, he is an active member of the BIS Committee for the Fire Resistant Glass and a member of the Glazing Society of India. Welcome, Mr. Hatinder. We are delighted to have you here with us today, and we are looking forward to your insightful presentation on fire safety glass, a topic that is not just technical but also vital for the safety and well-being of everyone who steps into a building. Over to you, sir.
Thank you, Anvita, and it's a pleasure having me here. I guess yes, you rightly said it's a product which is very widely used, and now I would say, since with the technology, it should be rightly used. So with new innovations, new advancements, yes, there is a product called fire safety glass, which nowadays is very widely, I would say, with the awareness being used in India. But yes, what it is, still the awareness levels are slightly low in some parts of the country, which will help us to take it forward to the different, I would say, audience.
Yes.
I'll just share my screen.
Sure, sir. Yes.
So today we're going to talk about glass and fire safety. And before I get into more on fire-rated glass, I'll just take you through the basic aspects of how glass is made, and then different what are the different assumptions that whether toughened, wired, or different type of glass are fire rated or not, and other things. So to start with, what really is the importance of fire safety glass? Actually, when we say glass comes into the passive fire system part of the application. As the name suggests, yes, it is used for compartmentalization, very widely used. And it's not only glass, there are a lot of other materials which are used for the compartmentalization. But yes, it has to be I would say compartmentalization is very important, because we have to contain the fire when there is a fire in a building, so that it does not spread to the other areas. And more importantly, nowadays, these fire-rated glasses, or the rather, I would say, when I say fire-rated glasses, I really mean the fire-rated system solution, which will also be covered in due course. So fire-rated, these system solutions, which form a part of the building application, they can be actually integrated with different, I would say, BMS, and form a part of smart firefighting solutions also. I would also say that they generally, these passive and active fire systems, they go hand in hand. We cannot design a building where we have only active systems, or we cannot design a building where we have only passive systems. Yes, they complement each other, and they have to be used togetherly and designed in such a way that it provides an easy egress to the occupants of the people during fire. So when we talk about fire protection as glass as a medium over there, yes, fire rated glass are of different types. Certain glasses are there which withstand the fire. They don't break in case of they are exposed to extreme heat when there is a fire in a building, but they allow heat transfer. And then there are certain type of glasses which don't break in case of fire, and then they limit the heat. And then further there is one more category of fire rated products which really limit the heat and give complete insulation as if it is a brick wall. And with the technology and all those advancements, there are a lot of products, and really this technology, with this advancement or innovation, new I would say fire rated products are being developed, and a lot of innovation is also R&D is going into place, which will really help in future for different architects or designers to use such products in their buildings and provide an easy egress to the occupants. More important is that when we use fire rated glazed fire rated solutions, which has glass in that, glass gives you transparency, visual benefits. It can be combined with any multifunctionality, and suppose we are able to see the fire and detect the fire, then definitely we can cut down that fire in the initial stage. More important, laterly we can also see that these fire rated glass solutions, they really help or they really aid the firefighters, because these are the people who actually enter the building when the fire is actually at a very advanced stage. So for them it is important to understand where is the fire, where is the seat of the fire, and such products will also help them to reach the seat of the fire. So before we go into the fire rated glass, I would just take you a few minutes to make you understand on how glass is made. So when we say glass has a couple of components, which the major component for glass would be silica sand. As you see, that it forms a 60% composition of that glass raw material part. Then we have soda ash, dolomite, calcite, and cullet. Cullet are nothing but these are broken glass pieces which are again used while manufacturing the glasses. But why cullet is used? Because these cullets really help to melt the whole batch of that raw material faster. That is why these cullets are being used as part of that particular batch. If you see now by screen, you will see we have a pictorial diagram for how the float line looks like. So we have a furnace here where we will put the raw material inside, and we will heat it around 1400 degrees Celsius. Then eventually that whole batch raw material will melt, and it will go to the float bath, where it will float on the molten tin. And here the temperature is close to 650 to 700 degrees Celsius. And from there, this will go to annealing layer, where we will cool the glasses gradually. And then it goes to the QC, where automatic laser detection is there, and cutting will happen. And then packing and transportation will happen. So this is the basic model where how glass is made. Now, when it comes to the fire rated glass, yes, these fire rated glasses, certain fire rated glasses, in that the raw material composition is slightly different. We will add sometimes alkaline earth metals so that we increase the melting point of the glass. As you can see here in the float bath, the temperature of the glass will go up to 600 to 650 to 700 degrees Celsius. Whereas when we add alkaline earth metals, or it could be a borosilicate glass, it can go up to higher temperature, even at 900 plus degrees Celsius. So this is how the different types of fire rated glasses are being made. Coming to the performance of glasses under fire, this is very important slide, because we need to know which type of glass will perform in case of fire. So when it comes to an annealed glass, the normal float glass, which we say annealed glass, it will break if it is exposed to fire within less than a minute. So it is not a fire rated glass. Wired glass, though it was when the fire rated glass itself started, I would say So it started with wired glass, but eventually these wired glasses have been phased out due to their drawbacks, and then people getting hurt due to the wire mesh. But these can take a temperature up to, can go up to rather 30 to 60 minutes only, and that to very limited size, when this is not a larger, I would say larger panes in when it comes to fire rating. The third category comes to is the tempered glass, which is the glass which is heated again once it is made, and then it is made stronger. So these tempered glass, when they are exposed to that fire, they will also break within less than 5 minutes to 4 to 5 minutes. They will immediately break. This is, and then there is a laminated glass, which is a glass which is being again laminated with polyvinyl butyl, which is called PVB layers. And then PVB being a combustible material, this will actually further add on to fire, and these glasses also break very fast. When it comes to double glazing, normal double glazing, I'm talking about ordinary double glazing with ordinary glasses, not fire rated glasses, this will also break within less than 5 minutes. So why these breakages happen when we say in all these classes? This is because these products, due to delta T, due to the temperature differential, the basic structure of these glasses is like that. They are not able to withstand that heat, and they break. And unlike the fire rated glasses, they can attain a higher temperatures, and then they don't break till the time frame it is being tested. Let's say it is tested for 1 hour or 2 hour, it will withstand fire or that heat for 1 hour or 2 hour. So when coming to the category of fire rated glasses, I'll cover the classification in coming slides. The monolithic glass, as I discussed, it will not break, but it will definitely transfer heat. It will withstand that fire for 30, 60 or 120 minutes, but it will transfer the heat on the other side, immediately on the other side, because when there is a fire in a building, the temperature will go up to 600 degrees Celsius within 10 minutes. So on the fire side, if we have 600 degrees Celsius, the non-fire side will eventually go to again 400 plus, 500 plus within very short period of time. That is again within less than 10 minutes, it will go to that much high temperature. That means I cannot cross that area, because I will die if that side is more than even more than 100 degrees Celsius. Then comes the other category of glass, which you can see on the screen, is the intumescent interlayered category of glass. So in this, you have two glasses which has a gel in between, which could be a patent compound for any company, different companies. And what happens to this interlayered gel? So interlayered basically is a compound which will foam up in case it is exposed to fire. So any side could be fire. These are bidirectional glasses. And what happens is that when in case of fire, the fire rated glass will break, and the interlaid will start exposed to fire, and it will start expanding. So what happens that when the interlaid expands, it will not allow the fire, even the heat, to transfer on the non-fire side. So that is the benefit of these interlaid glass. That means if there is a fire in a building, and let's say it takes 10-15 minutes to evacuate that building, at least for initial time frames, depending on which category of product we are using, the heat will not transfer, and I can easily cross the non-fire side without feeling any heat. Other side could be even 1000 degrees Celsius. So I'll just run a short video to give you a short brief how we test these glasses.
Welcome to the world of fire testing. In this short clip, we would like to introduce you to fire resistance testing of glazed building elements. The objective of the fire testing is to measure the fire resistive performance of a glazed building element to prevent loss of integrity, to limit heat transmission or temperature rise, which might cause the spread of fire. We do this by simulating a fully developed fire in a severe given situation. These fire-resistant elements are mainly used for fire compartmentation, limiting the spread of fire to other rooms and to protect escape routes for the evacuation of people. In the test furnace simulates a room fire after flashover when air temperature rapidly rises. The flashover point is the moment of near simultaneous ignition of most of the directly exposed combustible materials. The fire-resistant glazed building element is installed in front of the furnace. During the test, measurements are taken and observations are made on the opposite side of the fire. Fire resistance tests are conducted according to standardized test methods that outline in detail how the test must be conducted and which criteria need to be fulfilled. Most of these test standards follow the standard time temperature curve according to ISO 834. The test conditions are measured and controlled with plate thermometers and pressure sensors to accurately ensure reproducible results. After just 3 minutes, the temperature in the furnace rises to more than 500 degrees Celsius, which is 900 degrees Fahrenheit. After 30 minutes, the temperature has risen to almost 850 degrees Celsius, which is 1,600 degrees Fahrenheit, and continuously rises throughout the test. 3 hours into a test, the temperature can rise to over 1,100 degrees Celsius, which is 2,000 degrees Fahrenheit. On the opposite side of the fire, temperatures are measured with thermocouples placed on glass and framing surfaces. The radiated heat of the tested element is measured with a radiometer. The acceptable size and significance of cracks and gaps which may open during the test are measured by gap gauges or with the cotton pad test. Video and photographs as well as notes are used to ensure a complete documentation before, during and after the test. After the building element has proven its performance over the intended time, the test is stopped in a safe and controlled manner. Once the element has cooled down, it can be further analyzed. Building elements that successfully pass the test and for which a report is issued are eligible for classification according to the relevant building regulation or local requirements.
So as you can see, these testings are very important, and the more important is the labs where we do the testing, because all these labs should be accredited labs. That means they are fully calibrated, they are certified, and from there we get the certification, which is called a third-party certification, and only based on these certifications we are able to offer the solutions to the customers. So coming to fire safety types, this is important, which we discussed initially. The first type is called integrity type. It is denoted by E, and it means that the particular glass or a particular material will remain stable in fire. It will not fall, it will not break for that much time frame, could be 30, 60, 120 minutes, but heat will transfer. So this is the basic category of fire rated glasses, and generally we recommend these glasses only where we see in the design of a building that there will be limited portion or limited where there is an area where people are not going to egress that area, because if heat transfer, then it is it limits the egress of the occupants of the people. So it has a restricted, I would say, restricted usage in a building. Coming to EW category of products, this is the most widely used category in India, in other parts of the country, in Europe, in Middle East, or even in Southeast Asia. So this category is why this category is important. Why? Because this category is a midway category between E and EI. EW category, what happens that it limits the radiation as per the standard to, yes, it says 15 kilowatts, but yes, but of course 15 kilowatt is a very high temperature. But what happens that initially 20 minutes, 30 minutes, the radiation are even less than 1 kilowatt. And even for let's say approximately 45 minutes, radiation are close to 1.2 kilowatts. That means I can stand very close to the specimen. The other side could be even 1100 degrees Celsius without feeling heat. So that means in case of fire, I can easily cross that area if I'm evacuating a building. So that is why this EW category is very important, because it provides easy egress to the occupants. It limits the radiation, provides insulation also for particular time frame. And these radiations are measured. As you can see, there is a radiation meter at the center of the specimen. This is kept at the 1 meter distance only. It is not kept at more than 1 meter because the heat dissipation is very high. So that is why it is kept at a distance of 1 meter as per the standard. Then coming to the third category, which is I would say technically one of the best category, which is called EI category. This means integrity with insulation. And then integrity with insulation means that you have thermocouples on the non-fire side, and the maximum temperature on those surface should not, or on the thermocouple should not be more than 180 degrees Celsius. So what happens when we say it should not be more than 180 degrees Celsius, it means that the heat is very less than 1 kilowatt. Other side could be 1000 plus degrees Celsius, but I will not feel any heat on the non-fire side. So it is as good as a transparent wall. So this EI category could be EI 30, EI 60 or EI 120 category. So now this is a very short video which shows the difference between E category and EW category, and which will really give you, though it is not done in a live fire furnace as the initial video which you have seen, but it still gives you a better idea that how to differentiate and what is the performance of these glasses.
When it comes to fire safety, there is no second chance. This video will showcase the comparison between two kinds of fire-resistant safety glass through a live demo. Integrity E-rated glass stops the fire and remains intact for the time frame of its fire resistance period. The intense heat transmitted to the non-fire side may result in spontaneous combustion of objects, and it could impede the safe passage of the occupants. EW rated glass keeps its integrity during the event of fire and also controls radiant heat transfer to the non-fire side during its resistance period. The benefit of using an EW rated glass will be demonstrated through a simple experiment at the World Glass Complex of Saint-Gobain at Sri Perambudur, Chennai. On the left is a highly toughened monolithic integrity E-rated glass. On the right is an EW rated glass including an intumescent interlayer between two toughened glass panes. A piece of cloth and paper are stuck on both the glass panes fitted into a frame. They simulate objects on the non-fire side at an event of a fire. What do you think will happen to them?
On the left side, the paper has transferred due to transfer. Whereas on the EW side, it is intact, and even we can touch that side immediately. Other side is still
The items stuck on EW rated glass remain totally intact, whereas the combustible materials on the E-rated glass have vanished completely. Knowing the right choice of glass is the first step towards safety. Choose wisely.
So now coming to the applications with respect to National Building Code. So what our National Building Code says, as on date, it says that the fire exits and the doors in the building should have integrity, stability, and insulation for 20 minutes. That means with this criteria of insulation for 20 minutes, you are providing as an easy egress to the occupants of the building. This insulation criteria is going to increase to 30 minutes in the revision going forward. So which is a very good thing. That means when there is a fire, the occupants of the building will have an easy egress. They can cross that area and go down and escape and the buildings very easily, because there will not be any heat transfer. And this follows not only in the critical areas. It could be lift lobbies or other critical areas where AHU rooms, electrical rooms, where you really want to compartmentalize fire, and then your doors are actually insulated. So the exit door areas, exit requirements, it also says that they should be 2 hour fire rated, and then it also gives the dimension of the door. It should not be less than 2000 mm, because in case of there are a lot of occupants, there is a easy passage for people to move out of the building. This is very common design which we see on the screen right now. The lift lobbies, and then the lift lobbies are to be compartmentalized. Why lift lobbies are to be compartmentalized and pressurized is that because in case there is a fire, then there is a possibility the fire will go up, and then it will create a funnel effect, and it will eventually spread to a greater extent. So that is why in case the lift lobbies are part of the building, in the core of the building, they should be compartmentalized. And nevertheless, and they should also be with the most sometimes generally we see the occupants or the customers, they would like to have glass because they want aesthetics, they want visibility, and they generally go with EW category of products. This is one more application where when we say that as per the National Building Code, if you have a staircase and then you have a windows which are close to the exit staircases, that if they are within 1 meter, then it should be 60 minutes fire rated. This is what it says, because then if there is a fire and then people are crossing that staircase, the heat should not transfer to the people who are exiting the building. So that is why this area is also shown as fire rated. Refuge area forms a very important part of the building, especially high-rise building, because and then the areas at the height, which height there should be a refuge area, it is also defined like 24 meter and every 15 meters, and for different categories of buildings. What a refuge area does, suppose there is a fire, let's say at a refuge area, if let's say refuge area is at, let's say, 7th floor, there is a fire at 6th floor, then people will immediately move to a refuge area, stand there, so that they are then later evacuated from that refuge area, because that refuge area acts as a refuge for them, where they could be safeguarded. And this is a very common practice in India, and almost all high-rise buildings are mandatory to have a refuge area in their design. When coming down to residential buildings, all the exit doorways, specifically very important in residential, we see there are basements. All these basement car parkings, they should be fire rated. The doors should be actually fire rated with insulation EW category, because those are the areas, those are very vulnerable. If there is a fire in the car parking, the heat will and the cars will catch fire, the heat will transfer. So we really have to limit that heat, compartmentalize that area. So it is very important to have that. And all these these exit doors should have a panic bar, because it becomes very easy for the occupants. If they are running, they just push the panic bar and the door opens. Specifically, when it comes to the hotel kitchen areas, there the fire separation between the kitchen and the serving area, if that generally we see in a lot of kitchen areas in the hotels, is a glass. So that glass should be fire rated, because suppose there is a fire in that side, it should not spread towards the guest area. Then there are commercial buildings. In commercial buildings, the key areas which we talk about fire should be fire rated are exit doors, lift lobbies, refuge area, car parkings, and suppose there is an office which has a data server rooms. These server rooms are also compartmentalized properly with any fire rated material, I would say. And if there are doors, they should also be fire rated. Public buildings, when it comes to public buildings like or public specifically transports and all like metros, these areas are quite vulnerable because the human traffic is very high. There are a lot of people who use these medium to travel from one location to another. So in National Building Code, there is a provision. It is very clearly demarcated which areas should be fire rated, like their exit doors, kiosks, lift lobbies. Especially when it comes to the underground metro stations, there are smoke barriers which are top hung, and these smoke barriers should also be used because these smoke barriers they really channelize the smoke, and then there are suction fans which will extract the smoke out of that stations. Because most of the time we have seen when there is fire in a building, the people they die just because of smoke. So it is very important in those areas also. Here, as you can see in the slide, you see these smoke barriers. They are top hung, and they will channelize the smoke, and then this smoke is extracted from this side. This is very widely and very commonly used nowadays in India. A lot of metro stations, when you travel in the metro stations, underground stations, when you come through these escalators, you will see these smoke barrier systems are widely installed across India. And there is a specific standard for smoke barrier systems under which they are tested, and then they can actually withstand the heat up to 600 degrees Celsius. Why? Because when there is a fire, the smoke, generally when the tendency of smoke is to rise up, and this smoke itself is very hot. And then the standard says that this smoke can actually be as hot as 600 degrees Celsius. That is how they are tested. So coming to the benefits of the glass as such, I would say glass is a transparent material. It allows light. Nowadays, you know that we have solar control glasses. There are different type of glasses, offline or online coated glasses, which restrict solar radiations. So which really reduces the AC tonnage of a building, because less of heat is coming inside, and a better U value. So the glass can provide all these features, and also more important is that glass is a lighter material, so it will have less load on that building, and you can actually construct your facade at a very faster pace. Coming to the light transmission and the solar heat radiation, apart from that, when it comes to the light transmission, or more importantly the natural light, because we really want to avoid usage of artificial lighting, so glass will really give you that aspect to have more daylight inside. U value is also one of the aspects which is very important. If buildings are going for any LEED, GRIHA rating, there is specific value of U value which should be there, because U value is nothing but it is the amount of heat transferred due to temperature difference from inside to outside for per square meter area of glass. So a single glass will have a simple U value of 5.7 watt per square meter Kelvin. So when we double glaze it, it reduces to 3.9. When we use a coated glass, it can further reduce to 2.8 or even to 1.9 or even lesser with argon gas infill, and especially using triple layered silver coated glasses. So this can be reduced. And all these glasses, the benefit is that all these glasses can be combined with fire rated glasses. So we are talking about multifunctionality of these fire rated glasses. Very important, these fire rated glasses, when used, they really give you acoustic benefit, because let's say there is a partition and you have to use a fire rated material over there, and if it is glass, these specifically these interlayered glasses, they really give a very good acoustic benefit. They give RW close to 38 decibel, and it can go up higher also based on different combinations. So we really have an advantage of acoustic benefit when we use these fire rated glasses. As you can see here, different glasses will have different RW factors. Like single monolithic glass will have 32, 8mm will have 34. When we make DGU, it becomes 32. But in case of fire rated and all, it will further drop to 38 degree. Talking about they really give you safety, sustainability, comfort, and design. There are different, I would say, design parameters where we can use fire rated glass. And very important is that when we say fire rated glass, it always goes into the system, which will be covered maybe in the next part of the session. But the whole system has to be tested properly and then only used in the building. So coming about when you are using a fire rated glass, I would really emphasize that any product from any manufacturer, these are a couple of factors which are very important to choose a product, and ask your supplier that whether these glasses are UV stable, because when we use interlayered glasses, if these products are not UV stable, with time you will find that there is a bubble formation, haziness in the product. So UV stability is very important. Are there enough references? What about the manufacturer warranty and impact strength? Because all these products, most importantly, when these interlayered glasses are used, all these products should have impact safety. That means these are toughened fire rated glasses. Suppose there is no fire and then there is impact on the glass, it should not break easily. So that is very important. And are they manufactured in the proper audited facility, that is, it has been audited by third party? Because this really gives a comfort to the customer that whatever product they are buying right product, which has been certified, tested, and audited by third party. Yeah. Thank you very much for your time. Thank you.
Thank you, sir, for that insightful presentation. Your deep knowledge and experience in the field has provided us with invaluable insights that enhance our understanding of fire safety glass. I'm confident that your presentation has cleared up many misconceptions and highlighted the critical role of fire-resistant glazing in building safety. We have learned so much from your presentation, and it has sparked our curiosity to delve a little more deep into the subject. A lot of points that which have already been covered. So to further our understanding, we would like to take this opportunity to ask you a few questions.
Yeah, sure, please.
So, given the current advancements in the material science that we briefly dwelled upon the presentation, what are some more emerging technologies or innovations in manufacturing of fire-rated glass that you see in future that's happening under the wraps?
See, as I would say, the demand, or I would say not only demand, the need, or the architects, they look for a very special design, and then to come up their expectation, definitely we as a manufacturer have to really innovate our product. So I really see a lot of innovation and going into this field. There are a lot of solutions already being innovated, like butt joint fire rated solutions, because which has no frame, even a frameless fire rated doors. And more importantly, you see fire doors are actually one-sided openable generally in India. Some innovation is going on to develop both side swing, double side swing fire rated doors. So there is, I would say, a lot of scope also in this field, and which will really help architects and the customers to address their needs, I would say.
So in your presentation, we initially saw about smart firefighting, which kind of led me to our next question. How can fire-rated glass be integrated with smart building technologies? For example, are there any innovative ways where fire-rated glass is being used in conjunction with smart sensors or any other technologies?
Yeah. So as I said initially, also when we say fire rated glass, I would always say as a fire rated system solution. So yes, it's very important, and nowadays it's very widely used that we have solutions for, let's say, a sliding door which is 2 or fire rated. which can be combined with building BMS system, access control, or even your swing doors can be combined with automatic swing operators and all those things. So these products, they give an advantage, yes, that they can be combined for these active systems, so that it really helps people to design a building.
That's great. And we spoke a little bit about customization also, sir. So how does this customization of fire-rated glass vary for different sectors largely? For say healthcare, education, high-rise residential buildings, and what are the unique challenges you face when producing it to sectors like these?
When you talk about customization, yes, there are. I mean, sometimes we get a requirement that they want a curved glass, they want something shaped glasses and all that. Yes, it is possible, and it is possible in fire rated glass system solutions. So these customizations do happen based on the need of client. And when it comes to the different customization need based, like commercial building or a hospital building, it varies. Let's say in hospital, you have patients who will take time to egress. So for there, you would really like to propose a solution which is giving more amount of insulation, so that they get an easy egress, because they will not themselves be able to egress it. So they need certain aid to do that, which will take some time and all that. So yes, the customization happens in these areas.
Yes, absolutely. So in projects where design aesthetics are very crucial, especially commercial fancy areas, how do we balance the need of this visual appeal that the client wants while stringently looking at the safety requirements of the fire-rated glass?
It's a very good question. Yeah, because most of the time we see, yes, we want a fire-rated solution, but then outside it should look like this. So yeah, as you have seen that we can actually integrate these fire-rated glasses with any type of glass. It could be a solar control glass, it could be a ceramic frit glass which has any pattern. So we've supplied to Muscat Airport, their whole facade is ceramic frit, which is a fire-rated. We have supplied a couple of projects in India where the glass is IGU, and then they wanted some pattern on the glass. So it is possible. We can have fire with bullet also. We have blast solutions also. So there is a lot of I would say innovation technology into this industry.
Yes, that's great to know, sir. And also today we've predominantly focused on the fire safety, but I'm also curious to know if there's anything beyond fire-rated glass that you would suggest. For example, what are other architectural precautions or design strategies you would recommend to enhance the overall building safety, not just fire, maybe with respect to design for any architect?
I would say yes. When there is a fire, I mean the building has to fight from within itself. So the building should be self-sufficient to fight from within itself. That means it should have proper active system, proper passive systems, and very importantly, compartmentalization and sub-compartmentalization. I guess in India, the concept of sub-compartmentalization is still less. Yes, with a lot of IT companies, lot of occupants in the plate area is very large. The number of people sitting in that floor is quite large. It is important that we sub-compartmentalize those areas and have both active and passive system in such a way that the occupants are safe.
Correct. Absolutely. Oh, so this brings me to the last question, sir. So can you share insights on how Vetrotech collaborates with architects and designers in the early stages of a project to optimize the use of fire-rated glass? We've discussed a little bit about it, but how do we start from stage one? Like, when is the starting point that an architect should approach you for this kind of design to meet their goals?
Yeah. So just to give you a brief, Vetrotech is a part of Saint-Gobain, and we were the first one to innovate with these clear, toughened fire-rated glasses, which are with interlaid gel, which is a patent Saint-Gobain compound. So we really collaborate with the consultants, facade consultants, architects, designer from the drawing board stage itself, because they share their design, their idea, or rather their dream, which we try to make it happen with our products, because sometimes they have requirement for certain elevation, certain design, could be ceramic frit, could be some shapes and all those things. So we really work with them from the drawing board stage. We sit with them on the drawings. we offer them solutions what exactly they're looking at, and then they accordingly adapt and then incorporate such solutions into their project.
Absolutely. So with this answer, we come to the end of the webinar today. So thank you, sir, for the enlightening presentation on the crucial topic of fire safety glass. And the knowledge you shared today is invaluable, especially as we continue to innovate every single day and push the boundaries of what glass can achieve in terms of safety and performance. And fire safety glass may be a niche subject, not well known by everyone like how we discussed, but we learned a lot today, and it plays an integral role in everyone's life to safeguard anyone who's entering a building. So thank you once again on behalf of Glass Academy and Ethos for joining us today and dedicating some time for us. Thank you.
Thank you, Anvita. It was nice and pleasure to have me here. I guess I really enjoyed giving this small session on fire safety. Thank you so much.
Thank you. Thank you, sir. That's a cut. Thank you so much.